Welcome to Brief Code. Today we're going over the most asked interview question at JPMorgan. Reconstruct original digits from English. So we're given a string S containing an out-of-order English representation of the digits from 0 to 9. We're asked to return those digits in ascending order. In other words, we're just given a bunch of shuffled characters and we're asked to retrieve the words from 0 to 9 from that. So looking at example 1, the string here can be translated to the words 2, 1, 0, which then can be translated to the numbers 2, 1, 0. And if we return that in order, that would be 0, 1, 2. Looking at the constraints, the length of S is from 0 to 1,000,000, and S consists of characters from the words 0 to 9. Also, S is guaranteed to be valid. Let's take a look at another example. It's pretty obvious that this is 0, 2, 1, and 9. So how do we go about translating the string to the words 0 to 9? Well, first we can start with 0 and count the number of occurrences of 0 in the string. And we can see that it only occurs once. Next, we can move on to 1. We know that there's definitely one occurrence of this. But actually, there's 2, because we can use the O from the 2 and the N and E from the 9 to represent 1. But how do we know that the correct answer is actually 1 instead of 2? How do we make that decision? Well, if we look back at 0, we know that there's only one occurrence of this in the entire string. And how do we know that? Well, there's only one Z in this entire string. Let's go back to 1. 1 shares an O with 0 and also shares N and E with 9. So it's not really unique. Moving on to 2. 2 has a unique character W. 3 has a unique character R. 4 has a unique character U. 5 doesn't have any unique characters. 6 has X. 7 doesn't have anything unique. 8 has G. And 9 doesn't have anything unique. After taking a first pass from 0 to 9, we can try taking a second pass for the remaining words. 1 now has a unique character O. 5 has a unique character F. 7 has V. And 9, since that's our last word, we can pick any arbitrary character. So let's go with I. Alright, now we can translate any shuffled string to the numbered words if we go through those words in the same order as what we had previously. Let's also highlight the unique characters. Going through all the words in this order, we can see that there's only one Z in this entire string. So we can eliminate all the characters in 0 once. Next, we see that there's one W in the entire string. So we can eliminate all the characters in 2 once. There are no U's, no X, no G's. There's one O for 1, so we can eliminate all the characters for 1. No R's, no F, no V. And finally, we're left with the characters for 9. And so we're done with the first part of our problem, which is translating the string to its corresponding number of words. Now we just need to return this in order. So that's just simply iterating from 0 to 9 in order. So we have 1 0, 1 1, 1 2, and 1 9. And that's our answer. One final thing to note is that when we look for 0 in this string, We're going through the entire string from left to right. And we're eliminating the occurrence of each character from the word 0. We need to repeat this for every word in the list of numbers. And because we're going through the entire string every time, this is a linear O-of-N operation. Is there a way to make this more efficient? Is there a data structure we can leverage? Yes, we can use the dictionary because it gives us a constant O(1) lookup. So what we can do is, first, build a dictionary that gives us the count of each character in the string. This is a linear O(n) operation. Next, we'll go through the number of words from 0 to 9, looking up the unique character of each word. So that can be done in constant time, and we'll need to do that 10 times. Finally, we can iterate from 0 to 9 in order and build a string for our answer. Each number can be done in constant time, and we're doing that 10 times. This gives us an overall time complexity that's linear, O(n). Also, our memory complexity is constant, O(1), because we're storing the counts for at most 26 alphabetical characters in our dictionary. Alright, now let's code up the solution. The first thing we need to do is to build a dictionary that gives us the count of each character. So we'll go through each character in the string and increment the character's count by 1. Next, we'll build our words list. This is the number of words that we need to go through in order. The first word is 0. We'll need to look for the unit character Z, and this is the number that it represents. Next is 2. We're looking for W, and we'll put down the number as well. I'll just write out the rest of the words to speed things along. Now that we have our words list, we'll need to track the final counts of each translated number. We can store that in an array. The index represents the number from 0 to 9, and the value represents the counts of that number. We can now iterate through words list, looking for that unique character in our dictionary. If that exists, we know that there are exactly that many counts of this number. We'll also need to make sure we decrement the counts of each character in that word from our dictionary. Finally, since we have the final counts of the numbers 0 to 9, we can just iterate through them in order and build a string for each number. So let's say we have 0 and it occurs 5 times. This will return a string of 5 zeros. We'll then just join all the strings together to build a final string and return. And we can see that our solution is accepted. If you found this useful, please like and subscribe. Also, feel free to comment down below on which questions I should cover next. Until then, remember to keep your solutions brief and good luck.